Hello, everyone. Appreciate you being here for this session, dedicating your time. My name is Filipe Scoton. I'm Solutions Architect for the financial services industry at Amazon Web Services in Brazil. My role as a Solutions Architect is to help customers create new workloads or migrate existing ones to the cloud. This is session M14. We're going to discuss how to apply machine learning to help detect financial crime. So a little bit about the agenda. There's going to be some introduction on financial crimes and especially money laundering and anti-money laundering policies. Some of the challenges that financial institutions see as difficulties to adopt these technologies on that specific case. Innovative approaches using machine learning, some of the benefits, and a little bit of how to get started. So let's start with a baseline introduction to make sure all the terminology along the presentation is clear. This is not a deep understanding of financial crime, but I'll be mentioning some things along the presentation. So what are financial crimes? It could be an individual, or it could be an organization that's going to obtain money and benefit from the proceeds of that illegally or by deception made money. To have a picture of how big this is globally, there's a report from HSBC that says that almost 3.6% of global GDP is related to financial crime. So to have an order of magnitude, this is in the order of trillions of dollars yearly. It's a lot of money. A few examples involve fraud. It could be bank, it could be credit card, medical, corporate fraud. One example of these in real life in the last years is the Mossack Fonseca archives, also known as the Panama Papers, for those who never heard of it. This is 11.5 million documents. It's more than 2.3 terabytes of data that leaked from a law firm. And it exposes more than 200,000 accounts. This goes from tax evasion to corporate fraud, a little bit of everything. It was huge. It still has repercussions today. Another example is market manipulation. For those who remember that great movie from 1987, Wall Street, and remember the character interpreted by Michael Douglas, Gordon Gekko, we could see a little bit on fiction, but of course inspired by reality, of what a person could do buying, selling stocks, closing firms, doing all sorts of things to manipulate the market. Another example, theft, scams, bribery, forgery. Another movie, not that old, but it's almost 20 years, I guess. It's Catch Me If You Can. And the character played by Leonardo DiCaprio used to do forgery on IDs. So he did a little bit of everything. This was inspired by a real-life person. He was a doctor, he was an airplane pilot, and he was benefiting financially from all of these forged identifications. And the fourth one, and of course there's much more examples of financial crimes, but these are some of the most relevant for this presentation. Fourth one is money laundering, and we're going to dive a little bit deeper on this one. There's a case quite recent. It started about 5 years ago in Brazil called Operation Car Wash. For the Brazilians in the room, it's Lava Jato, Operação Lava Jato. And it started as a money laundering investigation on one specific person, and throughout the years it led to the largest corruption scandal in Latin America. This is in the order of billions of dollars. More than 100 people was already arrested, and it is in prison, including 2 former presidents. This is huge, and it started as a money laundering investigation. So let's dive a little bit deeper on money laundering. What is money laundering? It's the process of trying to conceal ill-gotten funds by passing them through the financial system to make those funds appear legitimate. So the name is quite suggestive, is getting dirty money from illegal activities and cleaning it through the financial system. Several crimes are financed and directly related to money laundering. This could go from tax evasion, drug dealing, human trafficking, and even terrorist financing. So as we saw in the previous example of Operation Car Wash in Brazil, it started on an investigation on one individual, and they realized with time that it was much broader case of corruption, tax evasion, there's money flowing to the traffic and a little bit of everything. It's just huge. Criminals will use different kinds of techniques, of course, to make this money appear legitimate. There's a lot of creativity there. I'll highlight one of them specifically, which is called Smurfing. So for those who never heard of it, this is probably the most basic and standard technique used by criminals. The idea is to have small cash deposits made by several different individual accounts, and all of that money is going to get transferred to a common recipient. So let's see how that works. Could be a criminal organization of, let's say, 10 members. Each one has an individual account and is going to deposit at the beginning of the week $1,000 on its own account. At the end of the week, they're going to transfer this $1,000 to a common recipient, a new account. And what we're going to have at the end of the week is $10,000 flowing across these accounts weekly. Why is it that standard, and why is it that hard to catch? So financial institutions and regulators, of course, they're going to try to create policies and define some thresholds. So in this case, it could have a threshold of $10,000, which means if there's a deposit or wire transfer of $10,000, this could pull a trigger, generate an alert, and somebody would investigate that deposit or that wire transfer. Of course, criminals, they know those thresholds, and that's why they do Smurfing. They split it into smaller deposits and on wire transfers to go below the threshold. So we have the same $10,000, but instead of one deposit and one transaction of $10,000, we have 10 of $1,000. And it gets harder, actually, because this could be done in different layers, in several layers. So this last account, it could be just another account, and from this one, could just transfer to another one and get it deeper and deeper, which is even harder to track. That account could be on another bank, and some banks, they don't share information. Some countries do have policies for information sharing, but most of them won't share information, so you just lose track of this money flowing and these transactions. And even worse, this could be a different bank offshore, overseas, on a different country, where there is no bilateral agreement to exchange information between countries. So it's probably even harder to track. They will add some variance, so they won't do it weekly on these same accounts. They'll stop for a while and get back after some weeks or after some months. So it's basic, it's quite standard, but it's so hard to track and so hard to identify. Those thresholds that I mentioned, it's just one example of a much larger thing called AML policy. AML stands for anti-money laundering. These are policies created by the financial institutions and by regulators to, of course, try to identify those suspicious transactions. Why is it important, and how much does it cost for financial institutions? So to give you some numbers, an idea of how big is this. Per year, the cost for compliance for the financial institutions in the US and Europe surpasses $20 billion. So in other words, financial institutions in the US and Europe, they're going to spend more than $20 billion each year just to be compliant with the regulations regarding AML policies. How is this money used internally? They will keep investing in people, in manual controls, and systems, of course, to automate those controls and create those rules. Some financial institutions are going to create specific compliance programs for specific countries, specific product lines, specific segmentations of customers. They're going to keep adding staff to areas with the weakest control, trying to raise the bar all the time and be more prepared for the regulator. Even thinking about this large amount of money, according to the World Economic Forum, it does not appear to be working. So if we dive deep a little bit into those, we can see that over the last decade, from 2008 to 2018, more than $26 billion of fines related to AML, to know your customer, and sanctions-related offenses were issued. Of that, 7.3 billion is specifically related to anti-money laundering policies. There are regions and countries like North America and Europe that represent a larger amount of those fines, and this is related, of course, to how hard the regulators are going to push policies to the financial institutions. So higher regulated countries tend to receive more fines. Even so, if we look not to the fines, but to the money intercepted in Europe, per year, investigation units intercept just 1% of the $1 trillion laundered each year. So if we look at the percentage, it's almost nothing, right? It's just 1% of money intercepted. But if we look into the absolute number, 1% of 1 trillion, we're talking about $10 billion intercepted. This is $10 billion that are going to finance all kinds of criminal activities, as we mentioned, drug dealing, tax evasion, human trafficking, terrorist financing. Why is this number so important? It's not working. If we do something a little bit different and increase by a little, it's quite significant. For those who never worked on a financial institution or never worked on these areas, how does an AML policy work within a business? This is a high-level view, of course, but how is it done today? First of all, there's monitoring of customer transactions. Of course, this is not monitoring of every transaction for every customer. These are sample transactions on sample customers, and those customers could be defined by being politically exposed people or people that maybe raised some alerts previously, even if they were false positives, some specific segments of customers, some specific or high-profile companies that operate on different countries and flow a lot of money. But at the end of the day, it's just a sample of customers and a sample of transactions of those customers. It goes through a rule-based system, which is going to raise an alert for money laundering if it finds something. Like, for example, what we mentioned previously, the threshold of $10,000 of a single transaction. This could just raise an alert. This alert will go to an internal investigation team. It's going to perform a manual review. It's a team of subject matter experts capable of analyzing those alerts. For them, it will be made available all of the data within the bank's systems. They could also leverage third-party data and some public information, mostly not just for individuals, but mostly for corporations and organizations. And if, after multiple reviews, if there is any indicative of money laundering, they will file a SAR, which is a suspicious activity report. So let's look at that again. Basically, we're monitoring a sample of transactions of a sample of customers, flowing it through a rule-based system, which could be actually an IT system, or could be just a group of people with gut feeling analyzing those transactions based on some rules. If they find something, or if the systems find something, they will forward it to an internal investigation and due diligence team. They will use as much data as possible, and if they find something, they will file a suspicious activity report, which is going to go to the regulator or the proper authorities for analysis. This is just an indicative of a suspicious activity. It's not an affirmative state that this is actually being money laundering flowing through accounts. It seems quite straightforward. It's being done by decades in major financial institutions. Some of them could do with more people or less, more automated systems or less, more sophisticated rule-based systems or less, but it's done. But as we saw, it does not appear to be working. And there are some challenges here. Of course, as we mentioned, the monitoring of the customers, maybe it could be better if I could monitor more transactions of some customers or even more customers. I could have more data. But this is hard from a technical perspective and from a practical perspective, and in terms of getting support from the regulator on things like privacy of these customers and things like that. These systems, there are some studies that state that 90% of the alerts generated by these systems are false positives, which means 9 for every 10 alerts that are going to be analyzed by the internal investigation teams. They're just false positives. They don't mean anything. It's hard to prioritize. These guys, they will have trouble accessing data. So all of the data will be available, but they have to have access to that data. And I'll stop here, and I'll not spoil next slide. So let's dive deeper into the challenges that financial institutions see for using machine learning and advanced analytics for this specific purpose of anti-money laundering and financial crime. So first of it, financial institutions, will keep facing challenges that will erode the effectiveness and efficiency of their AML policies. This is mostly related to data aggregation and analytics. In other words, the quantity of the data, as we saw earlier, the amount of transactions, for example, for the amount of customers that I can monitor, and the variety of data, either internally from different systems or externally from public sources. So there's poor quality of data and non-standard data structures. Sometimes there's a lot of fragmentation, fragmented sources, fragmented platforms, fragmented systems, a little bit of information here, a little bit of information there. The high rate of false positives, as we mentioned, it will make the life of these people even harder if they don't have proper access to information and information from previous false positives to learn from it and apply on the new ones. There are inconsistencies on identification, on screening, and at the end of that process, the SAR, the suspicious activity reports, there are some inconsistencies there as well. So this is important because the story of a customer inside a financial institution starts on customer onboarding. The first data intake about that customer and the lifetime of that information that needs to be updated from time to time. This could tell a lot about the profiles of that specific customer, being an individual or a corporation, an organization. So if there's no consistency when that data comes into the systems, you can imagine that everything from that point is going to get even harder. And to close, there's a lack of reliable quantitative metric to assess risk. But what does that mean is, remember that lots of alerts are going to be generated. 90% of them will probably be false positives. So how do I score those alerts to actually know which ones should be prioritized for the teams to analyze manually later? So apart from the data aggregation and data analytics, if we look specifically into the machine learning models, there's the soundness, accuracy, and transparency concerns of that model. So I have heard from different financial institutions that machine learning models are seen as black boxes. So they say that the inner logic of those models is not considered to be transparent. And this is interesting, and this is mostly related to deep learning models, which are, as you know, they are hard to explain. It's a complex math, different kinds of layers, different relationships. It could be explained, but it's quite hard. That would take them to a difficulty on justifying and validating the outcomes from those models. So if it's not transparent to me, how do I make sure I understand what are the results that come from these models and inferences? They're highly regulated, so they have to explain this to regulators, how decisions were reached and how those outcomes came to be. And as we talked about, this has been done by decades. So this is a new tool for something that they are used to do for decades. So there's a lack of confidence on the accuracy. So they know how accurate they are today with the teams and systems and techniques that they leverage today, but they will question every new model to be inserted, especially those seen or perceived as black boxes. So let's talk about the innovative approaches, and let's talk about how machine learning can help in these cases. So first of all is the idea of using supervised learning algorithms. I'm pretty sure most of you know, but for those who does not know what a supervised learning algorithm is, it's nothing more than a machine learning task of learning a function that maps inputs to outputs based on examples of input-output pairs. So let's step away from the financial services cases for a little. It's pretty much like teaching a machine learning model to detect hot dogs by giving images. It could be pictures or drawings of a hot dog as examples. So I'll just say to the model, this is a picture of a hot dog, and this is a drawing of a hot dog. And if I do it several times, it's gonna identify the patterns and know that every time it sees that pattern, it's a hot dog. I could do it for hot dogs, I could do it for dogs, cats. I could do it for suspicious activities or anomalous transactions. So how to apply it and what are the outcomes? First of all, it's important to say that these models are trained, tested, and optimized by humans, by subject matter experts, SMEs working with data scientists. They can be trained to deal with new alerts by using information passed to reviewers on previous cases. So what does it mean? That example with hot dogs, I'm going to teach the algorithm, the supervised learning algorithm based on previous examples of reports that were filled. It can help acting as a level 1 reviewer. It can help score cases and therefore helping on prioritization. So acting as a level 1, this model can look into the transactions, look into the alerts, and help scoring them prioritize so the internal investigation team, when they do due diligence, they know what to attack first. And there's some analysis and studies done by McKinsey that says that these kinds of algorithms can actually help reduce the amount of false positives by 20 to 30%. So let's switch from the supervised learning algorithms. Let's go to unsupervised learning algorithms. So as you can imagine, unsupervised learning algorithms, it's just learning without a teacher, or also known as self-organization. The idea is that it can identify patterns on data and reacts based on the presence or absence of those patterns. So something, again, that step away from financial services a little to see that in our real life. Every time somebody goes into a website to buy, let's say, running shoes, this person is going to receive a recommendation for buying running shirts, running shorts. This is an inference based on association. So it knows that this is basically running, and people that usually buy shoes or shirts or shorts for running, they're going to buy the other pieces of clothes as well. So pretty much the same thing could be applied in this case, and identify and create baselines of patterns and segment transactions from typical banking behavior to suspicious activities being done on accounts. So another application, it could be used to identify hidden patterns. So since they are not being trained by a human, not being told which categories to look for, can just identify new categories or new segmentations, or combine different categories and different segmentations into new ones. So one example, it could create a category looking into a segment which is entities that engage in large wire credit transactions. Another one that have also high frequency counterparties. And also large number of unique originators. These are three different segmentations that could make sense together into a new kind of category for example, corporations or companies. Every time it finds a transaction outside of normal parameters of this specific category, it's going to raise an alert, and it's going to go for further analysis. But as we discussed, these models are seen as or perceived as black boxes, and this gets worse in this kind of case with unsupervised learning, where new categories are going to be created. So banks and regulators are going to ask, how is this important? Is this really something that I should dive deeper and look and send to further analysis or not? And this is a reasonable question, because actually there's something here learning by itself. So the approach here is to use the idea of ML ops. So for those who come from the IT, maybe you have heard the expression DevOps. This is similar. It's not the same, of course, but it's similar. And it's similar on some of the concepts that DevOps brings in. In this case, we're going to have the subject matter experts working together with the data science to make sure that these models are transparent and robust. And they're going to use some techniques to change the perception that this could not be controlled, or this could be still being seen as a black box. One of them, the first of it, is really to improve governance over every step. So since from data intake, from the customer onboarding the financial institution, creating his account, until transaction monitoring and due diligence. Every code done to these models, either supervised or unsupervised, doesn't matter. So every code and every data of every parameter should be properly stored on version control systems. Why? They are going to dictate how these models are going to perform on production, so they should be treated properly. Training data should be treated as production data, because training data, especially if it comes from production, so if it's real data, not synthetic data, it should be treated as well as the production data with the higher level of security. It should be properly stored, because this is the training data that's going to dictate, again, with the parameters, how this algorithm is going to perform in production. So if I store all of this information, I should expect at any moment a given state of a model to be reproducible. It does not mean that I'm going to have the same result, the same model, because as we know, especially for deep learning, the first values for weights created, there's some randomness there. But if I do training the same way, with the same data, on same code, with the same parameters, the same way, at the end, it should converge to the same results, of course, within a certain limit of similarity and accuracy. One example is if I hire 2 people to participate on that due diligence internal investigation team, I'm going to have a process to train them, and I expect them to do the same level of analysis, but they're not going to do it exactly the same way. but I'm going to standardize the process as much as I can to make sure that the level of accuracy for both of them will be pretty much the same. This is the same idea here. Of course, I could go on, and we could just discuss that. Okay, let's just open that model and interpret what it's doing at the deepest level of understanding. It could be done. It's math at the end of the day. It could be done, but it's a huge effort. So sometimes it's just not worth the effort. If I'm controlling lots of things, I'm going to implement release pipelines or CI/CD pipelines to increase the level of automation, and with that, repeatability and security enforcement. Talking about security, I want to control user access to these models. So if this is production grade, I don't want everyone changing things as they please. And training data, as I mentioned, it should be treated as production data. So it should be encrypted by default. If it's not encrypted, have some automation to prevent training jobs from ever happening. So again, this is not opening the model for analysis every time it raises an alert, but understanding deeply what the framework chosen does, what the algorithm does, all the parameters involved, all the code generated, all the training data used, controlling it all, automating the process to making sure that I have this standardized process and that this algorithm is going to perform the way it is expected to do. So another approach is network modeling. This is just the idea of graph theory. So network modeling is a form of data visualization. It can connect different pieces of data and extract some insights from raw information. It could create graphs, put it on a graph database, for instance. So it would take all of the time series data of transactions, put it on a graph, and use graph theory to monitor centrality of nodes, connected components, active nodes, see the flow of money through these different nodes and accounts. Thinking about segmentation, we could look and detect some roles and communities. And we could do PageRank, which is, for example, the trustworthiness of associated accounts by transfer of measure for other connected nodes. So let's give an example of this. Let's say my wife and my mother have an account for years on a financial institution, and I just opened mine on the same one. By using graph theory, I could transfer measures of score risk from them to me, from their nodes to my nodes, based on the idea that they're good customers, they're good citizens, never raised any sort of alert, never gave any kind of problem to the financial institution. And since one of them is my mother and the other one is my wife, it is expected that I have a lower risk because I'm connected to them. This is called, within the financial industry, it's called a co-signer system. It could be modeled on a graph or on a network. And of course, you want to do it on the cloud. So inside a cloud, you can actually centralize and store data to fuel advanced analytics, as well as allowing financial institutions to make the most flexible and powerful use of infrastructure and services. These are complex calculations and complex models performed on increasingly large data sets. Amazon Web Services, AWS, has the broadest and deepest set of tools and services, either for analytics and machine learning. Some examples of it: you could use AWS Lake Formation to quickly build data lakes for analysis and use the different sorts of databases, such as Amazon Neptune for the network modeling, for example. You could use Amazon SageMaker to quickly build, train, and deploy those models, either supervised or unsupervised. You could use code pipeline and code commit to create the release pipelines and version control codes and parameters. You could use AWS security services to encrypt data, to control user access and identification, to control the configuration of the AWS resources. But there's a lot of room here for discussion on different kinds of services. So let's see some of the benefits of using such technologies. First of all, it's important for you to know that regulators are actually encouraging financial institutions to experiment machine learning on detecting suspicious activities. This is happening in Europe. This is happening in the US. Why? Because they know that this is a hard problem and it's just not working. And it has to leverage a new set of tools if we want to solve it. You can improve efficiency and effectiveness of the investigation by reducing the number of false positives. Remember, just by adding a supervised learning trained algorithm as a level 1 reviewer, I could help the internal investigation team to work on a smaller number of alerts and prioritize alerts. We could uncover new patterns by applying anomaly detection. It could provide faster adaptation to new criminal techniques. So why is this important? Remember, when I showed the rule-based system, it's how does a rule-based system works? It's just implementation of rules. So I first have to know these rules in order to implement them. So it's straightforward to assume that I'm always going to be one step behind the criminals. When this kind of technology comes in, I can faster adapt to these new techniques. Since we're talking about financial institutions, we have to talk about risk. And these are some benefits specifically related to the financial institutions. This is not related to regulators or country policies on money laundering and financial crime. This is actually improving the internal risk management framework by using these technologies. So first of it, we could enhance data governance, could respond faster to changes in the business environments. So we're talking here about implementing lots of different controls, but on a more automated way. So the risk teams within financial institutions won't be seen as a blocker, but actually responding faster to the needs of the business. And they can integrate risk management into other critical activities and critical processes that I actually almost didn't mention, but one of them is KYC, know your customer. Remember that data intake at the beginning of the process and keep knowing who that customer is or who that company or individual is, updating the profile and things like that. This could also leverage from these technologies. Another one is fraud detection, which is quite important for financial institutions. How to get started? should I fire everyone and just exchange it for artificial intelligence? No. No matter how intelligent models are, they cannot be expected to operate without human oversight and testing. So people are still critical, and humans will continue to be an integral part of the process, even after the model is put into production, always reevaluating and seeing if it works, changing, adapting for new techniques. So ML models can perform the function of a level 1 reviewer. In this case, humans will be responsible for checking and deciding if those findings and alerts should be forwarded to other teams or not. The SMEs, the subject matter experts, will test and optimize the models, working closely with the data scientists. And this is a sum of knowledge, of course. One knows a lot about machine learning, data analytics. The other one knows a lot about the processes and what the criminals are doing. And the SMEs will also be responsible for working closely with the regulators. So they will be responsible for explaining and justifying the use of these technologies to make it more clear and transparent for the regulators. At last, these concepts or these approaches, these ideas should be deployed in a business-specific way. So first of all, financial institutions and regulators, they have to develop an end-to-end tech-enabled KYC and AML process. This goes from the onboarding of a customer to monitoring and due diligence. The whole process should be more tech enablement and more entangled with the concepts that we saw. And they should also define a strategy for data quality and data aggregation. As we saw, quantity and variety of data is important, so good quality data is important. Aggregation of these different sources and fragmented platforms is also important. After these definitions or thoughtful planning, it should be embedded more organically into business processes. So it's really applying it and starting small and then scaling fast. So let's say include simple models into current systems and processes. As we discussed, for example, we could have the level 1 reviewer, or we could just have a model operating as a shadow of the normal process. It's reevaluating the findings of a rule-based system, adding some information, aggregating, risk scoring, and other things. And at the end, you have to implement some KPIs to measure either efficiency and effectiveness, to be sure that these models and these approaches are actually doing what they're supposed to do, that they're bringing the results that were expected, either internally for the financial institution as well as for the regulator. So analytics, machine learning, and all of these ideas and technologies, they are important, but they alone will not provide a silver bullet for all challenges related to anti-money laundering or related to financial crime. But what is important here is, as we saw, this is a new approach. This is being stimulated by regulators. Because if we can just cause a small dent on that number that we saw, a small one, this is quite significant. So it should be considered by every financial institution. With that, thank you very much for being here. If you have any questions, I'll be around. and have a nice event.